Types of fracture. Fracture mechanics can also be classified based on the type of fracture, such as ductile fracture. This type of fracture occurs in materials that can undergo significant plastic deformation before fracturing. Ductile fracture is commonly observed in materials such as metals and polymers, which can undergo large strains before fracturing. Ductile fracture is typically characterized by the formation of necking and void growth before the final fracture occurs. Brittle fracture. This type of fracture occurs in materials that have little or no plastic deformation before fracturing. Brittle fracture is commonly observed in materials such as ceramics and glasses, which are relatively strong but do not undergo significant plastic deformation before fracturing. Brittle fracture is typically characterized by the formation of a crack that propagates rapidly through the material, leading to sudden failure. Fatigue fracture. This type of fracture occurs due to cyclic loading and the accumulation of damage over time. Fatigue fracture is commonly observed in materials that are subjected to repeated loading and unloading, such as metals used in aircraft structures or turbine blades. Fatigue fracture is typically characterized by the formation of small cracks that grow over time until a critical size is reached, leading to sudden failure. Creep fracture. This type of fracture occurs due to long-term exposure to high temperature and stress, causing gradual deformation and eventual failure. Creep fracture is commonly observed in materials that are subjected to high temperatures and stresses over long periods, such as turbine blades in power plants. Creep fracture is typically characterized by the gradual deformation of the material over time, leading to the formation of cracks and eventual failure. So, the behavior of a crack, such as its rate of propagation, does indeed specify the type of fracture. To simulate this, we need powerful software. ABEX crack simulations are great because they're really good at understanding and showing us how these cracks grow. Now that you have a good understanding of the fracture mechanics overview, let's delve into the fracture analysis methods required for ABEX fracture simulation. 1.4 Fracture Analysis Methods. Fracture analysis methods are used to analyze the behavior of materials under loading and to predict the critical stress or displacement required for crack initiation and growth. Linear elastic fracture mechanics methods assume linear elastic behavior near the crack tip, while elastic plastic fracture mechanics methods account for elastic plastic behavior. Linear elastic fracture mechanics methods typically involve calculating the stress intensity factor or the strain energy release rate at the crack tip, while elastic plastic fracture mechanics methods involve calculating the J integral or the crack tip opening displacement using plastic zone size correction factors. Other fracture analysis methods include cohesive zone modeling, continuum damage mechanics, and fracture toughness testing. Some of the mentioned methods could be used in both LEFM and EPFM, but with their proper modifications. You can watch the complete course of fracture mechanics and fatigue concepts theory and ABEX software implementation on Udemy from the link in the description. Thank you for watching, subscribe for more, and see you next time.